In this section, we will discuss about measures of frequency. Measures of frequency is a statistical measurement that is implemented in order to summarize the values in the dataset. In other words, it makes it easier for us to understand the dataset. It can be represented in the form of a table, a graph, or a chart. There are two types of frequency distribution. The first is grouped frequency distribution, and the other is categorical frequency distribution. Grouped frequency distribution is used for the purpose of quantitative analysis, and categorical frequency distribution is used for the purpose of qualitative analysis. We will look into each of these in details. So first, we will look into grouped frequency distribution. For performing grouped frequency distribution, the first step is to collect the data. Data can be collected from various sources, as we have seen in the introduction section. Then next is organizing the data. So organizing the data comes in a few steps. The first is arranging the data into an array, and then deciding on the number of classes, then calculating the class intervals to determine the upper and lower limits of the classes, and finally making the tally sheet. We will look into an example to understand these steps in more detail. So here we have an example of, we have scores of 25 students of a class. These are the scores, and we have to grade these scores under the grading scale of A to F. So first step involves organizing the data. So we have organized the data into a tabular form, into an array. The next is defining the class. So we are already given here the grading scale. So the grading scale is our classes. The next is class boundaries. So here we need to define the upper and lower limits of these boundaries. So you may notice that the lower limit of class is same as the upper limit of the next class. This is done because we do not want any gaps between these classes while distributing the data. So you may ask, are these numbers counted twice? No, these numbers are not counted twice. Let me tell you. For example, in grade A, the marks are counted from 91 onwards till 100. So we are excluding 90. And similarly, in grade B, the marks are counted from 81 onwards till 90 including. So excluding 80. So because 80 is already included in the class C, as 90 is already included in class B. Similarly, for class C marks scores will be included from 71 onwards till 80, because 70 is already included in class D as upper limit. So, and also for 60 for class D, the marks will be included from 61 onwards till 70, because 60 is already included in the grade F. Because of this, these classes are called as mutually exclusive classes. I hope you get the idea, you got the concept behind this. So we have defined the class boundaries. Now we will prepare our tally sheet. So while preparing our tally sheet, tally is nothing but counting the number of entries. So for grade A, we have to count the marks, the students who scored the marks between 90 to 100, that is 91 onwards. So we will count it: 100, 94, 98, 93, 100, 97, 98, 99, 100, 99, 93. Okay, so how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 students who scored marks between 90 to 100. Similarly, we will do this for grade B, that is from 80 to 90. So 89 will be there, 86 will be there, 83 will be there, 82 will be there, 84 will be there. Okay, so how many do we have? 1, 2, 3, 5. We have 5 students who scored marks between 80 to 90. Similarly, for grade C, from 70 to 80, 75, 72. Okay, so here 70 will not be included in grade C because 70 is already included in grade B. So we will have to score the, we will have to, no, sorry, the scores will be from 71 to 80, excluding 70. So 70 is already, 70 will be included in the next class. So we have only 2 entries for this. Sorry for that. Okay, for grade D, we need scores from 60 to 70. So 1, 2, 3, and 4. Here, okay. 70 will be included in grade D. So we have 4 entries. And the rest of will be for grade F, that will be less than 60. So here it is 43, 1, 2, 3. So we have 3. Now we will total this to get the total number of students. So 18, 25. So we have 25 scores. This means that we have not skipped any data point here. So this is our concluded distribution table of this example. One thing to note here is that these data points are discrete in nature. That is, these data points are at least at a distance of 1 data point from each other, and also are in full numbers. So these data points have a discrete nature. So next example we will see will have the continuous nature, that is they are in what we say, decimals or not whole numbers. So here we have example of weights of 15 people with weights, and we have to classify these weights under these predefined classes. So first step involves arranging the data. So here we have the data arranged. These we have allotted these people with numbers randomly for our understanding. And the next step is to classify, to define the classes. So we are already given the classes, so we just made these into a tabular form. The very next step is defining the class boundaries, defining the upper and lower limits. So the upper and lower limits, so we have assigned underweight for the weights which are less than 60. Normal weights will be from 60 to 90, and overweight will be anything greater than 90. Here we have, here 60 is not included. Similarly, as we have seen in the previous example, so this normal range will start from 61 to 90 onwards, 61 onwards, excluding 60. Similarly, for overweight, 90 is not included in overweight. 90 is excluding 90, that is starting from 91. A little disclaimer here is that this data is purely fictitious and is not related to real people. The class boundaries defined here are just for the purpose of understanding the concept. We do not intend to spread body shaming. This is made solely for educational purposes only. So we will tally these, we'll prepare tally sheet. So we will assign how many data points comes under which classes. So first is underweight, that is less than 60. So which we have here is 45, 1, 51, 2, and 59, 3. So we have 3 people who comes under 3 weights that will be in underweight class. For normal, from 60 to 90, that is starting from 61. So 1, 2, 3, 61. 4 and 5 and So here we have 90, but it is greater than 90 because it is 90.6. So decimal, it is greater than 90, so it will not be under normal. So we only have 5 entries for normal class. And rest will be for the overweight, that is 1, 2, 3, 4, 5, 6, 7. So here 90.6 will not be included in the normal because normal range ends at 90.0. So it's 0.6 greater than 90, it will be included in overweight. So we have to add these so that we get 15. This means that we have not missed any data points here. So this is our concluded distribution table. Next, we will look into the next frequency distribution type, that is categorical distribution. Categorical distribution includes non-numerical data. So here we have an example to understand it better. So in this example, game user has collected 35 characters. These are the characters here. So we need to prepare a frequency distribution table for this data. So first step is arranging the data into an array. So we have arranged this data into a tabular form for make it view better. So next step involves classes, defining the classes. So because this is non-numerical data, we will only use the characters themselves as classes. So here we have it, and we don't, because this is non-numerical data, we don't have to define the upper limits and lower limits of the classes. So we will finally jump to preparing the tally sheet. So we will start counting. We'll start counting the entries for these characters. For bag, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 entries for bag. Next, we will do similarly as we have done in the previous examples for water. We have 1, 2, 3, 4, and 5. We have 5 entries for water. Stone. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 entries. Sorry. Similarly, we will do it for metal. Where is it? 1 metal, 2. Okay, so we have 2 metal, and the rest will be for bread. So 1, 2, 3, 4, 5, 6, and 7. So we have 7 entries for bread. Since we have total number of characters are 35, so we will add these tally numbers to get 35. Okay, this means that we have not missed any. We have not missed any of the data points here. So this is our frequency distribution table. So let's look into applications of frequency distribution. So here, frequency distribution table is very useful for representing the raw data in an organized form, so that it is easy for us to read and understand. The next is it gives us detailed analysis of population data when we apply a characteristic to it. So for example, I have a population data of a country, and I want to look into the educational background of the people of that country. So I will only search for the education part. So this is the characteristic. Like this we can analyze. The next is the application. The major applications are in the sales and marketing. For them to find the trends in the market, for them to make better business decisions for themselves. In medical research, it is used in, for example, to understand the effects of drug on a particular organism, and in behavioral studies, by conducting observation on a person or something, we can find different patterns of behaviors, etc. In education, as we have seen in our previous example, we can apply this frequency distribution table, frequency distribution on the marks scored by the students to understand the performance of students better. In science and engineering, it is applied to understand to determine the rate of change observed in a periodic phenomenon, such as mechanical vibrations, audio signals, or radio waves, or light waves, etc. So this is the end of this section for measures of frequency. In the next section, we will look into the next measure, that is measures of central tendency. Stay tuned and see you there.